Okay, good morning, students. Yesterday we have seen till logic levels. So here we are different diagrams are there for both the TTL as well as CMOS voltage levels. So both input and output. This is the input logic levels. This is the output logic levels. And similarly for CMOS, input and output logic levels are there. Suppose this is input VIH. V VIH minimum, VIH minimum, that is 2 volts, and VOH minimum is 2.4 volts. Under such conditions, if you see the logic margin, that is high state noise margin, VNH is equal to VOH minimum minus VIH minimum, 2.4 volts minus 2 volts, that is a 0.4 volts is the noise margin. So this is the noise margin when a signal is moving, when a pulse is moving from input to output, input of the logic gate to the output of the logic gate, there are changes in the waveform, that is a pulse waveform. So that is the because of the characteristic of logic gates, it enters into a some margin called a logic margin, that is a noise margin, which is defined like that. VNH is equal to VOH minimum minus VIH minimum. The values will be given. So you are supposed to ask a noise margin, VNH. Similarly, low state noise margin. This is high state noise margin. Low state noise margin is VIL max, VIL max, VOL max, VIL maximum. So this is a 0.8. This is a VOL max. So this is a 0.4. 0.8 minus 0.4 is the 0.4 volts is the logic margin. In this way, so noise immunity, which is the ability of the circuit tolerance when changes from input to output. So these are about noise margin. Next title is logic families. When we come across logic families, first thing is all digital ICs are made up of some logic gates. You know, all digital ICs, maybe 74 series, maybe 4000 series, or C, TTL, etc. Whatever it may be, they are of digital ICs. All they made up of some logic gates. Internally, there are gates. So these logic gates are fabricated, means designed and manufactured with a suitable technology called logic families. The IC consists of logic gates with a suitable technology called logic families. The type of logic families are, it may use for their fabrication bipolar devices. Bipolar devices or mass devices or both. If it uses some bipolar devices, then they are called bipolar logic families. If they are uses mass technology, metal oxide semiconductor devices technology, then it is called mass families, mass logic families. Sometimes few ICs are hybrid families, that is both bipolar as well as mass technology for few of the devices internally, then it is called hybrid technology, both bipolar as well as mass, it is called bimass family. So bipolar families consist of DL, diode logic. Only diodes are fabricated internally. Then ECL, emitter coupled logic. Emitter coupled logic. Emitter of the transistors are coupled in the logic gates. So that is why it is called ECL logic family. Another logic family is RTL, register transistor logic. Registers and transistors are used for the fabrication of gates, logic gates, OR gate, AND gate, NOT gate, etc., known as RTL, register transistor logic. DTL, diode transistor logic. Next, TTL, transistor logic. As the improvement in the technology, because of power consumption, space for fabrication, compactness, economic, etc. So lastly, they come to final stage, that is TTL logic family. Even TTL are somewhat large in size compared to MOS. When MOS family is invented, so PMOS, P-type MOS technology and NMOS and complementary MOS, both N as well as P, they are used for the fabrication of logic gates, hence the name MOS family or CMOS families. Complementary means one is PMOS, another one is NMOS. PN alternately, that is called complementary MOS family. Then hybrid family is BiMOS, both technology they have. Further, the TTL subfamilies includes based upon their standard values and low power consumption, high power consumption. They are classed into standard TTL. They are denoted by 74 series or 54 series, 7400, 5400 for NAND gate, etc. 7408, 5408, like that for AND gate. OR gate 7432, 5432. So this is a standard one. Whereas low TTL, they include 74L, 54L. L is included in between. Then high 54H, 74H, high power TTL. Then Schottky. Schottky means a type of diode, Schottky diode. Somewhat symbol is like a Zener diode. So it is fabricated differently with the collector open. So that is called Schottky diode. So those Schottky technology here, again standard Schottky TTL, they are, S is used. 74S, 54S is used. S for Schottky. Again, Schottky is further divided into low power Schottky, high power Schottky, advanced Schottky. For low power, LS is used. High power, H is used. Then advanced, A is used. A notation is used. So accordingly, 74H, 54H, high power. 74LS, 54LS are low power Schottky TTL, so on and so forth. So then the CMOS families. CMOS families includes 4000A, 4000B, 4000UB, 54 or 74C, C for CMOS, 54 or 74HC. HC includes high power CMOS. HCT and 54 AC, advanced complementary. ACT, like this, they have been manufactured. Advanced CMOS technology, like that. So next, ECL subfamilies. ECL means emitter coupled logic. ECL is a standard emitter coupled logic family, and it was introduced by ON Semiconductor in 1962. ON Semiconductor, a name of the manufacturing industry. The first product launched of this family is MECL1 series, later MECL2 series, 3 series, 10K series, 10H series came into existence. So this is the ECL subfamilies. This is about introduction to different logic families and their subfamilies. Now let us see the logic gates using this technology one by one. The first diagram shows diode logic. It is called diode logic. Diode logic. Only diodes are used. Y is equal to AB. This is AND gate. Whereas here, second one is resistor transistor logic. RTL it is called. Here resistors and transistors are used. So here Y is equal to A plus 1 complement is the A plus 1 complement is the, this is a NOT operation, or A is one standard, another B with A complement. So this is a, in this way it is manufactured. See, diode transistor logic, whatever may be the gate, technology is important here. So here technology is diode transistor logic, DTL, diode transistor logic. Resistors only few, but never take part. That is why it is called DTL, diode transistor logic. This is output is A dot B whole complement. That is not AND gate. An AND gate it is. So these are different specifications with respect to different logic families. The characteristics of different logic families. Parameter is there. Number of basic gates used in the fabrication. RTL, NOR gate is used. IIL, NOR gate used. DTL, input injected logic it is called. DTL, NAND gate is used. Standard TTL, NAND gate is used. ECL, OR gate. NOT and OR gates are used. MOS, NAND gate is used. CMOS, NOR as well as NAND gates are used. OR and not OR, NOR is used like this. So different power dissipation capability in milliwatts, fan out, noise immunity, propagation delay, speed power product. These are the different specifications. Fan out especially for this basic gates, that is RTL family 5, IIL family depends on the injector current, depends on the injector current, the current injection based on which number of gates are connected, means power consumption or power dissipation capability or a power supply from the power supply. The DTL, so this is 8, TTL 10, ECL 25, MCS 20, and CMOS total 50 fan outs. Fan out is number of output gates it can able to drive. So up to 50 gates it can able to drive. These are the different specifications. Go through it, keep it in memory. In the exam they will ask. This is about propagation delay. When it is moving from input to output, this much delay will occur. This is propagation delay in nanoseconds. Nanosecond, 25 to 250. The 12 nanosecond, 30 nanosecond, 10, 2, 300, 70. So much time delay. Speed power product is there. So comparison of logic families. So CMOS and TTL we can compare like this. So different values are there: power dissipation, propagation delay, maximum clock frequency, speed power product, fan out. Based upon these parameters, the ICs are used in practical purposes. These are the things. Go through the literature and you will get. Now TTL NAND gate and its operation. For your syllabus, TTL NAND gate is there. TTL NOT gate is there. Inverter is there. CMOS inverter. As per your syllabus, the slides are introduced here. Not all the gates. Few gates are for your syllabus. Here, basic TTL NAND gate and its operation is there. So here it consists of this one. This is called two types of connections will be there in TTL NAND gate. One is called a totem pole. In totem pole, T3 and T4 they are connected in series with the power supply. T3 will be a top on the T4 is a top on T3. A top on T3, so that they will be connected in series and output is taken from T3. As far as working is concerned, so just case 1, case 2 is there. Go through the literature. At least one input is low. When one input is low, any one of the input is low. Here in the circuit diagram, you see it is a emitter coupled logic. Internally, it is emitter coupled logic. Even though it is a TTL family, input gate is emitter coupled. A, B, C, three. So one transistor has three inputs, A, B, C. When one of the input is 0, this is connected to ground. When this is connected to ground, so no voltage is available for T2. T2 never conducts, it is cut off. When it is cut off, T4 is also cut off, T3 also cut off, because it is driving one through collector, another through emitter. So this is output is high. When cut off, output is high. When input, any one of the input is low, output is high. That is not AND gate. At least one of the input is 0, the TTL transistor T1 saturates, thus the base of T2 is almost 0, T2 is cut off, T3 cut off, T4 functions as emitter follower. T3, T4 functions as emitter follower. Whatever emitter input is there, that is output. Output is high, not low. Output is high, that is when in any one of the input is 0, output is high. So this is the function. So here output is taken. So T3 is cut off, T4 functions as emitter follower, voltage to load, output is high, that is Y is equal to 1. Similarly, condition 2, each input is high, then this is the condition. Go through the literature. So accordingly it works. So anyway, it is NAND gate, not AND gate. When all are 1, output is 1 in AND gate. But when all are 1, output is 0 in a NAND gate. For other conditions, it is high. Any one of the input is 0, output is high. When all inputs are high, then only output is low, opposite of AND gate. So this is called a totem pole, because T3 and T4 They are connected in series. See here, the TTL NAND gate is a totem pole output. The totem pole output implies that transistor T4 sits at top T3 in order to give low output impedance. In order to give low output impedance. This is used for impedance matching. A low output impedance means a short time constant RC. Therefore, the output can change rapidly from one state to another state. This is what the importance of TTL, that is a totem pole. Similarly, one more connection is there for the same NAND gate, that is called open collector. So in this circuit, collector is not connected, so it is open. Under this condition, for a different combination, when input and output are 0, 0, output is cut off. When 0, 1, output is cut off. 1, 0, output is cut off. When 1, 1, 0, output is saturation. That is, input is 1, 1. Two inputs are there, output is 1. Only two inputs are there, output is 1. Output is low only when all the inputs are high. Otherwise, cut off. Cut off means high. If any one of the input is 0, output is high. When both here, A, B, 2 only there, both are high, then only output is low. So that is why NAND gate, it is open collector. Collector is open here. So CMOS inverter, the last one, the table shows CMOS inverter. Inverter means input is 0, output is 1. Input is 1, output is 0. So this is a connection for PMOS, this is NMOS, CMOS, complement of the other. One gate is made up of PMOS, another gate is made up of NMOS. So it is complementary. One conduct, another never conduct. So vice versa. Accordingly, output CMOS inverter, when Vin is 0, output is 1. Output is 1. When Vin is 1, output is 0, because output is taken from two common terminals. So one is grounded, another is connected to VDD. Because in MOS, both terminal drain and source are interchangeable. That is why common output is taken here. From NMOS, output is taken here. This is NMOS, another PMOS. With respect to ground, we are measuring. That is why output is NMOS only. When input is 0, output is 1. When input is 1, output is 0. So this is the working. Just to go through the literature. So this is works like this. When VDD applied, when input is 1, so this is short, so output is 0. When this is short, output is VDD. When V in 0, when V in VDD. V in high, output is 0. When V in is 0, output is VDD. That is high. So this completes the MOS. Properties of MOS inverters are CMOS inverter. There is their existence of direct between power supply and ground. It has a low output impedance. MOS inverter is always either VDD or ground. The voltage swing in a CMOS inverter is VDD equal to 0, hence VDD or 0, hence VDD. 3. As the gate of CMOS transistor does not draw any DC input current, extremely high. Inverter is extremely high. Resistance, input resistance of CMOS inverter is extremely high. So we need high input impedance and low output impedance in all electronic circuits for impedance matching. So this completes in all respects the Boolean algebra and logic families. Have any doubts you can ask? Yes, students? Devika? Yes, Devika? Devika? Sahana? Sagar?
हाँ सर.
Hello, Sagar?
हाँ सर.
Any doubts?
No sir.
So this completes your second chapter. In the next class, that is from Monday, we will have a new chapter, and in next week there will be test for you, online test, multiple choice questions. So Sunday from same time 9 to 9:30. Okay?
हाँ सर.
Sunday test ಇರುತ್ತೆ, ಆನ್ಲೈನ್ ನೆನ್ಪ್ಲೆ ಅಟೆಂಡ್ ಮಾಡ್ರಿ.
ಸಂಡೇನಾ ಸರ್?
ಸಂಡೇ ಬೇಡ,
ಅಲ್ಲ ಕೇಳಿದೆ ಸರ್ ನಾನು.
ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಸಂಡೇ, ಈ ವೀಕ್ ಅಲ್ಲ.
ಹಾ ಸರ್, ಓಕೆ ಸರ್.
1 ವೀಕ್ ಟೈಮ್ ಕೊಡ್ತೀನಿ.
ಹಾ ಸರ್.
ಆನ್ಲೈನ್ ಅಲ್ಲೇ ಸಬ್ಮಿಟ್ ಮಾಡೋದಿರ್ತದೆ.
2 ಚಾಪ್ಟರ್ ಮೇಲೆ ಸರ್?
ಹಾ, 2 ಚಾಪ್ಟರ್ ಮೇಲೆ.
ಎಸ್ ಸರ್.
ಅರ್ಧ ಗಂಟೆ ಟೈಮ್, 20 ಕ್ವಶನ್ ಕೊಟ್ಟಿರ್ತೀನಿ, ಜಸ್ಟ್ ಟಿಕ್ ಮಾಡೋದು. ನೀವು ಮಾಡಿದ ಕರೆಕ್ಟ್ ಮಾರ್ಕ್ಸ್. ಹಾ
ಸರ್, ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಸರ್?
ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್.
ಯಾ, ಓಕೆ ಓಕೆ ಸರ್, ಓಕೆ.
ಆನ್ಲೈನ್ ಇರುತ್ತೆ, ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ಮಾಡ್ರಿ, ಟೈಮ್ ಇಂಪಾರ್ಟೆಂಟ್. ಓನ್ಲಿ ಹಾಫ್ ಆನ್ ಅವರ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಟೈಮ್ಗೆ ಓಪನ್ ಆಗುತ್ತೆ ಅದು. ಅದಕ್ಕ ಮುಂಚೆ ನೀವು ಓಪನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಪಟ್ರೆ ಓಪನ್ ಆಗೋದಿಲ್ಲ. ಎಕ್ಸಾಕ್ಟ್ ಟೈಮ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, 30 ನಿಮಿಷ ಆದ ತಕ್ಷಣ ಕ್ಲೋಸ್ ಆಗಿಬಿಡುತ್ತೆ. ಎಷ್ಟು ಮಾಡಿರ್ತೀರಾ? 9 to 9:30 ಬೇಡ ಸಂಡೇ?
ನೋ ಸರ್, ಸಂಡೇನಾ?
ಹಾ, ಸಂಡೇ ಯಾವ ಟೈಮ್ಗೆ ಇಡ್ಲಿ?
ಹಲೋ
ಹಲೋ, ಹೇಳಿ
ಸರ್. ಸಂಡೇ?
ಹಾ,
ಓಕೆ ಓಕೆ ಸರ್, ಓಕೆ.
ಸಂಡೇ 9 to 9:30.
ಹಾ ಸರ್,
ಓಕೆ. Communicate others also, those who are absent. Have any doubts you can ask. Another 5 minutes for discussion. Yes? Including K-map and logic families. If you want to ask, you can.
ಸರ್, ನೀವೆಲ್ಲ ಚಾಪ್ಟರ್ ಮುಗಿದ್ಮೇಲೆ MCQ ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಕಳಿಸ್ರಿ ಸರ್.
ಹಾ, ಓಕೆ. ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆದ್ಮೇಲೆ ಆಲ್ 4 ಚಾಪ್ಟರ್ಸ್ ನಿಮ್ಗೆ MCQ ನೀವು ಗೂಗಲ್ ಸರ್ಚ್ ಮಾಡಬಹುದು.
ಹಾ ಸರ್.
MCQ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್ ಆನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್ ನೀವು ಟೈಪ್ ಮಾಡಿಬಿಟ್ರೆ ನಿಮ್ಮ ಮೊಬೈಲ್ ನಲ್ಲೇ ಬಂದ್ಬಿಡುತ್ತೆ. ಅಲ್ಲೇ ಓದ್ಬೋದು ನೀವು. ಓಕೆ, ನಾನು ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಂಡು ನಿಮ್ಗೆಲ್ಲ ಕಳಿಸ್ತೀನಿ. ಕಂಪ್ಲೀಟ್ ಆದ್ಮೇಲೆ ಕಳಿಸ್ತೀನಿ. ಇನ್ನ 2 ಚಾಪ್ಟರ್ ಇದ್ದಾವೆ, ಬೇಗ ಮುಗಿಸ್ಬೇಕು, 2 ವಾರದಲ್ಲಿ ಮುಗಿಸ್ಬೇಕು. ಅದು ಈಸಿ ಇದೆ, ಬರೀ ಸರ್ಕ್ಯೂಟ್ ಇರ್ತಾವ, ಡೈರೆಕ್ಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇರುತ್ತೆ. ಇದ್ರಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇಲ್ಲ. ಡಿಜಿಟಲ್ ಪ್ರಾಬ್ಲಮ್ ಟೈಮ್ ಭಾಳ ತಗೊಳುತ್ತೆ. ಓಕೆ,
ಸರ್ ಪ್ರಾಕ್ಟಿಕಲ್ಸ್
Start
ಆನ್ಲೈನ್
ಮಾಡು.
ಮುಖಾಂತರ ಮಾಡ್ತೀರಾ?
ಹಾ ಆನ್ಲೈನೇ ಮಾಡ್ಬೇಕಂತೀನಿ, ನೋಡೋಣ. ಆಫ್ಲೈನ್ ಆಯ್ತಂದ್ರು ಥಿಯರಿ ಇರುತ್ತೆ ಬರೇ. ಯಾವ ರೀತಿ ಕನೆಕ್ಷನ್ ಮಾಡಬೇಕು, ಯಾವ ರೀತಿ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್ ಹಾಕಬೇಕು, ಅಬ್ಸರ್ವೇಷನ್ ಟೇಬಲ್, ರೀಡಿಂಗ್ ತಗೊಳ್ಳೋದಿಲ್ಲ. ನೋ ಕನೆಕ್ಷನ್, ನೋ ರೀಡಿಂಗ್.
ಹಾ ಸರ್.
ಬಹುಶಃ ಹಂಗ್ ಮಾಡ್ಬೋದು. ಕಾಲೇಜಿಗೆ ಬಂದ್ಮೇಲೆ ಗೊತ್ತಾಗುತ್ತೆ, ಅಲ್ಲಿವರೆಗೆ ಗೊತ್ತಾಗೋದಿಲ್ಲ.
ಆಫ್ಲೈನ್
ಬಟ್
ಕ್ಲಾಸ್
ಆನ್ಲೈನ್ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಅದು ವೈವಾ ಮಾಡ್ತಾರಂತೆ. ಒಬ್ಬರೇ ಎಕ್ಸಾಮಿನರ, ಎರಡೆರಡು ಎಕ್ಸಾಮಿನರ್ ಇರ್ತಿದ್ರಲ್ಲ, ಒಬ್ಬರೇ ಎಕ್ಸಾಮಿನರ. ಅವರೇ ಏನದ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಬುಕ್ ಕೊಡ್ತಾರೆ, ಒಂದ್ ಯಾವ್ದೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಕೊಡ್ತಾರೆ, ಅದ್ರ ಬಗ್ಗೆ ಬರೀಬೇಕು ನೀವು. ಸ್ವಲ್ಪ ವೈವಾ ಕೇಳ್ತಾರೆ, ಮನೆಗೆ ಕಳಿಸ್ತಾರೆ. ನೋ ಕನೆಕ್ಷನ್, ನೋ ರೀಡಿಂಗ್, ನಥಿಂಗ್. ಅರ್ಥ ಆಯ್ತು?
ಹಾ ಸರ್.
ಜರ್ನಲ್ ಗಿರ್ನಲ್ ಬರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ.
ಎಸ್ ಸರ್.
ಥಿಯರಿ ಟೈಪ್ ಅದನ್ನು ಟೆಸ್ಟ್ ಇದ್ದಂಗ.
ಹಾ ಸರ್.
ಬಟ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಕ್ಸಾಮಿನರ್ ಇರ್ತಾರೆ, ನಾವಿರೋದಿಲ್ಲ.
ಹಾ ಸರ್.
ಯೂನಿವರ್ಸಿಟಿಯಿಂದ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಕ್ಸಾಮಿನರ್ ಬರ್ತಾರೆ, ಅವರೇ ಎಲ್ಲರಿಗೂ ಒಂದೊಂದು ಹಾಫ್ ಆನ್ ಅವರ್ ನಲ್ಲಿ ಒಂದು ಬ್ಯಾಚ್ ಮುಗಿಸ್ಕೊಂಡು ಹೋಗ್ಬಿಡ್ತಾರೆ.
ಎಸ್.
1 ಅಥವಾ 2 ದಿನದಲ್ಲಿ ಎಕ್ಸಾಮೇ ಮುಗಿತಾವ. ಓಕೆ,
ಹಾ
ಬಟ್
ಸರ್.
ನೀಟಾಗಿ ಓದ್ಕೊಳ್ರಿ. ಅದೇ ಥಿಯರಿಯಲ್ಲಿ ಏನು ಓದಿರಿ, ಅವೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇದ್ದಾವ. ಅದನ್ನೇ ಪ್ರಾಕ್ಟಿಕಲ್ ಯಾವ ರೀತಿ ಮಾಡ್ಬೇಕನ್ನೋದನ್ನ ನೀವು ಚಾರ್ಟ್ ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. ನಾನು ಹಾಕ್ತೀನಿ ಚಾರ್ಟ್ಸ. ಆಮೇಲೆ
ಹಾ ಸರ್.
ಕಾಲೇಜಿಗೆ ಬಂದ್ಮೇಲೆ ಆ ಜರ್ನಲ್ ಅನ್ನೇ ನಿಮಗೆ ಎಲ್ಲ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, ಒಂದು 8 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಕಳಿಸ್ಬಿಟ್ಟಿರ್ತೀನಿ. ಆ ಥಿಯರಿ ಪ್ರೊಸೀಜರ್ ಓದ್ಕೊಳ್ಬೇಕು, ವೈವಾ. ಯಾಕಂದ್ರೆ ಟೈಮ್ ಇಲ್ಲ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿಸ್ಲಿಕ್ಕೆ. 10 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ 4 ತಿಂಗಳಾದ್ರೂ ಕಂಪ್ಲೀಟ್ ಆಗೋದಿಲ್ಲ ಅವು. ಒಂದೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿಸಿದ್ರೆ ಎಲ್ಲರಿಗೂ ಇಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಒಂದೇ ಅಷ್ಟೊಂದು ಸೆಟ್ ಇರೋದಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತು?
ಹಾ ಸರ್.
Okay, stop here only. In the next class, if any information by the university, I will inform you.
ಎಸ್.
ಎಲ್ಲರೂ ಲಸಿಕೆ ತಗೊಳ್ರಿ. ಎಕ್ಸಾಮ್ ಫಾರ್ಮ್ ಬಿಟ್ಟಿದ್ದಾರೆ, ಎಕ್ಸಾಮ್ ಫಾರ್ಮ್ ಯಾರ್ಯಾರು ತುಂಬಬೇಕು ತುಂಬ್ರಿ. 4th ಸೆಮ್ದು 2nd and 4th ಸೆಮ್
ಹಾ ಸರ್.
ಯಾರ ಎಕ್ಸಾಮ್ ಫಾರ್ಮ್ 4th, 6th and 2nd ಫೀ ಕಟ್ರಿ, ಎಕ್ಸಾಮ್ ಫೀಸ್ ವಿದಿನ್ ದ ಡೇಟ್. ಮತ್ತೆ ಲಸಿಕೆ ಕಂಪಲ್ಸರಿ ತಗೊಳ್ರಿ, ವ್ಯಾಕ್ಸಿನೇಷನ್. ನೀವು ಮನೇಲಿ ತಗೊಂಡ್ರೆ ಇಟ್ ಇಸ್ ಓಕೆ, ತಗೊಂಡಿದ್ದಿಲ್ಲ ಅಂದ್ರೆ ಕಾಲೇಜಿನಲ್ಲಿ ಇರುತ್ತೆ, ಹೋಗಿ ತಗೊಂಡ್ ಬನ್ರಿ.
ಹಾ ಸರ್.
ಓಕೆ, see you in the next class.